There we go. As I mentioned, it's not going to be absolutely perfect. There are still going to be some marks in the cylinder there, but you can kind of see how it gives it a nice even pattern finish. And one of those things is the headlights here. You can see that they're very yellowed, they're very fogged over like most of these plastic headlights get after a certain time. Got the passenger side done. There is no denying that these things look completely different now with that procedure being done. Next up, we got a little bit of suspension work to perform. I noticed when I had the vehicle up in the air that the boot for the upper ball joint was completely, you can see it's just coming apart and crumbles, completely destroyed. Same thing for the lower ball joint and also the boot for the tie rod here, the outer tie rod. So basically all of these boots are destroyed, and you can't actually tell from here, but this upper ball joint is completely destroyed. There's a lot of movement in it. So I went ahead and bought a full kit off of Amazon that comes with new upper control arms, lower ball joints, and tie rods. I think it comes with end links as well. And it was all very cheap for the whole entire kit. I'll go ahead and post that link to that below so you can see. We'll go ahead and add that to our dollar total amount. But for right now, let's just go ahead and get into this. Now, because these are suspension related components and it does affect your alignment, you want to do the best you can about marking where everything is currently before you remove it. That way when you put it back in, you get it in generally the same spot. Now, anytime you do any sort of major suspension work like this, you're going to need to take the vehicle and get an actual alignment done afterwards. That way you can make sure it's all wearing correctly. I noticed when I pulled these tires off that they're wearing pretty good on the inner side of the tires. Pretty good sense that the toe was not set correctly on this truck, so it needed an alignment anyway. But we'll go ahead and get these suspension components replaced. Not that big of a deal. Now I can already hear you guys saying, hey, Sky, this sounds a lot like that Chrysler 300 you had. Why didn't you just get a junkyard engine for that car? And why didn't you just fix the suspension for that car? I am telling you guys, that car was literally not worth it. It was junk. This one, even though it is a little bit rough on the body, it's not too bad. The paint's in decent shape. Overall, underneath, you can tell it's in far, far, far better condition. It's so much nicer. It's not all bashed up and destroyed underneath. Still has all the factory components in there. You can tell somebody just drove this thing around like a regular vehicle. They weren't hot rodding it or anything like that. So this one is worth putting a little bit of time and a little bit of money into to bring it back to the road. So that's my little spiel there. Let's get into replacing the suspension. Just a couple of things I want to mention when you're doing this job. So after you get your nuts off for both the upper and lower, we're going to go ahead and take this whole entire knuckle assembly out of here. It's the easiest way to do this job. So once you get this thing to this point, what you want to do is remove the brake caliper and bracket assembly. Go ahead and hang it. Don't let it hang by itself, but use a bungee cord to hang it up out of the way. And then actually pull the rotor off. And the reason why you want to pull the rotor off is because the speed sensor here is mounted back here. There's one 5mm Allen bolt. You just take that out, slip the speed sensor out of the way, and now the whole entire knuckle assembly is ready to come out. Another thing you want to think about here is the outer tie rods. If you are replacing those, break this nut loose before you remove it from the knuckle itself, because of course, if you pop this thing loose and then try to undo this nut, it's very, very difficult. Usually these things are on very tight, especially if you're in a rustier environment. So break this nut loose beforehand. And now to get the actual knuckle assembly free, you want to break these ball joints loose. Now there's a variety of different tools you could use. However, I like to just refer to the old 3-pound mallet. And no, I'm not talking about hitting it directly on the bottom here. Although if you have to resort to that at some point, I won't fault you for that. No, primarily what you want to do is you want to shock the side of the knuckle itself, because this is a tapered fit, which it's like a conical shape that tapers down. So basically, if you can shock it enough, that taper will break free in there, and then you can pop it right on out. Same thing with this upper control arm right here. This is also a tapered fit, and the lower ball joint is also a tapered fit as well. So basically, I'll give it some smacks here right on the side, and hopefully we can get the tie rod to break loose, and I'll give it some smacks here right on the front. And this is actually under a little bit of tension, so as soon as I smack this thing and break that free, this should pop up at least a few inches, and then this whole thing will flop down kind of towards me. And then at that point, I'll be smacking on the lower portion of it to try to get this whole entire knuckle assembly to drop free off of the ball joint. That's what it's all supposed to happen in theory. Let's see if I can't make it actually happen. Fail. All right, so at this point, I can actually use the mallet to give it some taps here on the bottom. I will not be reusing this because I am replacing the outer tie rod end, so I can give it some fairly good smacks. But what you're trying to avoid is you're trying to avoid mushrooming the bottom of this so much to where the nut itself won't come off or go back on if you are reusing it. There we go. So I still believe that smacking it here on the end had shocked it enough to where some light taps on the bottom end here were all that was necessary to actually get this to come loose. Let's see what happens here on the upper ball joint. So the lower ball joint has already broken free from all that smacking that I did. So this upper ball joint should be really close. Don't really want to pinch my hands. There it goes. So this should just drop out of the way. There we go. So the whole knuckle assembly comes off and out of the way. And then you have great access here to the lower ball joint, your upper ball joint. You can see just how destroyed this piece is. It's just floating around in there. So that's definitely done for. Let's get a new one of these on here. Also notice the orientation of where this is right now. You want to go ahead and mimic that when you tighten this thing down, because if you tighten this up, these are rubber bushings, and if you tighten it with the A-arm facing upward like this, as soon as the vehicle gets down, or if you do it too far down, as soon as the vehicle gets down on its own weight, it'll be putting pressure on those bushings, and you don't want to do that. You want it to be just a neutral position when the vehicle has its weight on it. So I'm going to go ahead and mark the location of both of the bolts here. That way when it goes back on, I can mimic the alignment settings that it already has. We'll get this upper control arm out of the way, and then I want to take a look at this lower ball joint here. One more tip on these outer tie rod ends, much the same way as you want to mark your location of these upper camber bolts. On the tie rod ends, as you unscrew them, go ahead and count the turns. And that way when you put the new one on, you can put it on the exact same amount of turns. Again, it's not gonna be precise, but it's gonna get you in the region of where you need to be so that your alignment's not crazy out of place, so you can at least drive it to the alignment shop. So let's see what this one is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, well, just about 20. So right about 20 turns. So when I put the new one on, I'm gonna put it on the exact same amount of turns. We'll see what that gets us. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So right about there, I'm gonna loosely tighten this nut. There's no reason to try to get it tight now, but now that's basically ready to be reinstalled. Also, I think we may have verified that our lower ball joint is in fact faulty. Yeah, I think that was bad. So on our front end repairs here, we've got the new upper control arm in, we have our new sway bar end link in place, we have our new outer tie rod. Now the only tricky part about this job, the part that's really gonna be a little bit of a struggle, is the lower ball joint. Now you can go ahead and rent these tools, the ball joint presses, from your local auto parts store. I think they can rent them for a very cheap cost. Unfortunately, a lot of times those kits will have pieces missing from them, so you kind of have to mix and match to make them work. But it is necessary for the reinstallation of these lower ball joints because they are a press fit. Now to get them out, I basically just took my 3-pound mallet and just smacked on it enough, and it just drove it down through and popped the ball joint out of there, so that wasn't a problem. There are ways that you can, I don't know, rig something in a really shaky way to get this thing back in, but I don't recommend it. I definitely recommend getting an actual ball joint press tool. That way you can just, I mean, it makes it so much easier because you can just fight and fight and fight with these things. Then you get the actual tool for it and just tighten it up and whoop, just presses it right into place. So much nicer. So we've got the ball joint in here, the new one on the driver's side. All I gotta do is throw the one in on the passenger side and start reassembly of our knuckle. And we're gonna have basically all new front suspension components here. This thing's gonna ride 1,000 times better than it did before. So much better. No more play top to bottom. No more play side to side. This front end is done. Well, we've gotten most of our parts in for our engine refresh that we're doing. Now, what we're gonna focus on right now is we're gonna start getting that short block together. That means reinstalling the pistons and rods. We're putting some new piston rings on there and some new rod bearings. So that means we're gonna do some quick measurements on the block itself. I'll show you what we're gonna go through there and we'll get those things installed. So first thing we're gonna check here is we're gonna check the actual bore of the cylinders here to make sure these are a standard bore and that they've never been bored out in the past. I have been bit by that before. I'll go ahead and post a link to that right here. So what we're gonna do is we're gonna take our digital calipers here, and honestly, you know, to use the correct tool here, you'd be using a bore gauge, a dial bore gauge, which is a little bit more specialized. A lot of people won't have that. In this case, we're just looking for an approximation, so the digital calipers will do just fine for that. So let's go ahead and measure up our bore here. And we're looking at 99.43 millimeters, basically 99.5 millimeters. Now that is in fact the stock bore size for these. So these cylinders have not been touched. They are as factory, and that's really good news. So we verified that our bore is our standard bore here. Now the next thing we're going to do is check our piston ring end gap. Now what you're gonna do is you're gonna go ahead and place the ring into the bore. Then you use the head of the piston here, you flip it upside down and push it down into the bore about that far. And what that does is that centers the ring, makes it nice and flat, and then it makes it very easy to check that end gap, because if it's at an angle, you can mess with that gap and not have it read correctly. Now, one thing I want to point out here, this engine, or this block, has over 200,000 miles on it, or right at 200,000 miles, and we had to run a hone through it to clean up those cylinder walls. So my guess is that piston ring end gap is going to come in either at the very maximum allowable amount of end gap, or even maybe a couple thousandths above that. I want you to know that that is not a huge deal. It's not something I'm that concerned about. Obviously, it'd be great to be completely within spec, but a ring gap, piston ring gap that is like a couple of thousandths larger than the maximum, you're literally not going to notice that. It's not gonna puff excessively through the crankcase or anything like that. It's not gonna be a problem. Now, obviously, it's a different story when you're talking like a connecting rod bearing clearance or something like that. Those have to be within spec, but a piston ring end gap, as long as it's like 2 thousandths over the maximum, again, I'm not concerned. Those are my thoughts on it. Take that as you will. Let's move on. All right, I've got our top ring here. Let's go ahead and slip this into the bore. Again, use the piston to help push it down flat. Just like that. And we're gonna measure with a feeler gauge. The maximum allowable tolerance on this piston ring end gap is 15 thousandths. So let's take a look and see. Look at that. We're actually dead on with this. I'm a little bit surprised. I thought that was gonna be a little bit larger, but that is right at 15 thousandths. So that's fantastic. I'm gonna go ahead and check in some of the other cylinder bores just to see if there's a difference. There probably will be like very minor differences between each cylinder bore, but that tells you like we are right close in the neighborhood there. So I'm totally good with that. So after I check these others, I'm gonna go ahead and load the rings on all the pistons. We'll put some new connecting rod bearings in there. Let's get these pistons installed. So I feel like I need to point out yet again the reason why I'm recommending and doing stuff the way I am, because I know there's so many people down in the comments who are gonna be saying, you're a hack, I can't believe you put it together like that. Look, the point of this series is the cheap Hemi challenge. It's not about spend a ton of money and get everything done perfectly. That's not what it's about. It's about trying to get it together as cheaply as you possibly can with tools you might have at home to try to get that thing back on the road again. So that's what we're trying to do here. We have the block cleaned up. We have our measurements. We're pretty much within tolerance here. It's maybe right on the edge of that, but it's still within tolerance. And we're gonna get this thing back on the road, and it'll be a good, solid, reliable driver for someone. Now, it's not a race engine, so we don't need to break it down to really, really specifics. Now, of course, if you have the time, if you have the money specifically, it makes more sense to go all the way through this thing, get it fully rebuilt. What I'm doing here, I'm calling a refresh rather than a rebuild. This is just a quick, let's do some measurements, let's check some things, let's put it back together, get a nice, solid daily driver out of it. So I just feel like I need to point that out yet again for this series, but let's move on. So when you're putting piston rings on, you're gonna start with the oil slinger ring here, and it is this wavy looking ring. So that goes in the very bottom ring gap there. Go ahead and just, or ring groove, go ahead and just slide that guy in. And then you have the oil scraper rings. These are very, very thin rings. that go on the top and bottom edge of that wave ring there. They go in the same groove, they just go on the top and bottom edge. Now one thing you want to note here is that when you slip these guys into place, make sure that the gap, the end gap of the ring, is on opposite sides from each other. That way they don't line up. And these are pretty flexible, so they should just slide into place. There we go, there's one. And there's the other. All right, so our ring gaps are opposite sides from each other. Now we're gonna do the second ring here. And a lot of times with these rings, both the top ring and the second ring, they will have a different profile on them, which means if you look at them from the side, you'll notice that there's a beveled edge or something of that nature. On the factory piston rings, it has a dot to show you which side is the top of the ring. On this case, these are Molle piston rings, and it has a little M Molle logo on the top of the ring itself to show you that this side is the top side. Now when it comes to these kind of piston rings, it's best if you have a piston ring expander. It's a kind of plier that will open up this ring gap enough for you to slip the ring into place. I don't have that tool right now. I should, I don't. You can do it by hand, it's really not that difficult. But you do run a higher risk of actually fracturing the ring because these things do not like to deflect one way or another. They really are somewhat brittle. And if you tweak on them too much, you're gonna snap the ring. So just be real careful when you put it on. So again, make sure that the top side is facing up. And you can kind of just slide it around. There we go, into place. Now, when you're looking at the face of the piston here, you have your wrist pin here. The opening on the end of the ring should be about like this. It should be crossways. Like here's your wrist pin here. It should be crossways to the wrist pin at an angle there. And then, this is on your second ring. Then on your top ring, like say you're opening, in my case, here is on this side. The top ring, then you want your opening to be 180 degrees out on this side right here. Now these rings will spin and move as the engine runs, so it's not like the most critical thing, but it is important as you're putting it together to make sure that your ring gaps are dead opposite from one another. Helps prevent any combustion losses. Now the top ring in this case does not have a top or bottom side, so it can go on either way. Again, we'll just slip it into place and walk it around. There we go. And one last thing you want to do is make sure all of your rings are moving smoothly in the ring gap. You want to, if you're using used pistons, you definitely want to get in there with a little pick tool or something and clean out any of the soot that can get jammed or gummed up in there, because these rings need to be able to move freely the entire time, need to be able to spin and shift back and forth. If they can't, you're going to have serious problems, so make sure you clean that out. Okay, we've got all of our rings loaded up, our pistons ready to go. Let's go ahead and get our new rod bearings in and start putting these things in. All right, you guys, you know the deal. Go ahead and hit that subscribe button, hit that notification bell, especially so you see all the newest videos as soon as they come out. I want to thank all of you guys for supporting. Everything has been amazing lately. We'll see you next time on Reignited.